What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve any exponential equation, right? So I'm going to go over these 6 examples. So hopefully there's something here that can help you out. Other than that, let's start with the first one over here. I'm just going to get these out of the way, all right? You can jump around the video if there's a different one that you're kind of looking for, but we're going to start here. So here we have 7 raised to the 3x plus 5 is equal to 7 raised to the 1 minus x. Now, the goal with these is trying to get the same bases. So you can see we have a 7 here and a 7 here, right? So when we have the same base, the way we can solve this is by setting the exponents equal to each other. So then here we can just say that 3x plus 5 is equal to 1 minus x, right? And then here we just have to solve for x. So here we can, add x to both sides. We can subtract 5 from both sides. Those cancel out, those cancel out. So then here we get 4x is equal to negative 4. So then here we can see that x is equal to negative 1. All right, so then that would be our answer right here. All right, here's the next one. So we have 6 raised to the 2x minus 6 is equal to 36 raised to the 3x minus 5. So again, the goal is trying to get the same base, right? Here we have a 6. Here we have a 36. So this is kind of a common problem you might see. You might notice that 6 is a factor of 36, right? So 36 we could actually rewrite as 6 squared, okay? So then if we do that, we're going to have 6 raised to the 2x minus 6 is equal to 6 squared raised to the 3x minus 5. Okay, so now we have a power raised to another power, so then we just have to multiply these together, okay? So 2 times 3x minus 5. So we can basically just distribute this like that, right? So then over here we get 6 raised to the 2x minus 6 is equal to 6 raised to the, 2 times 3x is equal to 6x, and 2 times negative 5 is negative 10. Okay, so now you can see we have the exact same bases, right? 6 and 6, so we can drop those and then just set the exponents equal to each other. And sorry, I made a little mistake right here. It's not minus 6 like that. The whole exponent is 2x minus 6, okay? So again, we can set the exponents equal to each other. So 2x minus 6 is equal to 6x minus 10. Okay, so then we can move the x's. Let's move them to the right. So minus 2x, and then we can move the numbers to the other side, plus 10, plus 10. All right, so then here we get positive 4 is equal to positive 4x. So then here we get that x is equal to positive 1. All right, there's our answer here. All right, here's the next one. So 512 raised to the 5x minus 1 is equal to 1/8 raised to the negative 4 minus x. So one thing we can do here is actually turn this fraction, this proper fraction, and we can flip it upside down so we have a whole number to work with. Now, in order to turn a fraction upside down, or basically find the reciprocal, you just have to raise it to the negative first power, right? So 1/8 raised to the positive first power, basically how we have it right now, is the same thing. It's equal to the reciprocal of that, so 8 over 1, or simply just 8, raised to the negative first power, right? Just turn this exponent negative, so negative 1. So we're going to replace this 1/8 with an 8 raised to the negative 1. And the reason we're going to do that is because then we'll have a base of 8, right? And then you can see we have a big number here, so 512. So is there a way to rewrite 512 to have a base of 8? Well, there is, okay? Because 512, that's the same thing as 8 raised to the third power. Okay, so then that way they can both have a base of 8, right? So again, 512, we can rewrite that as 8 raised to the third power, and then that's raised to this guy still, 5x minus 1, and that's equal to 1/8, but we're going to rewrite it as 8 raised to the negative 1, and it's still raised to this guy over here, negative 4 minus x, okay? Now over here, again, we have a power raised to another power, so we just have to multiply those together. So 3 times 5x is 15x, and 3 times negative 1 is negative 3, right? So then here, we're finally left with 8 raised to the 15x minus 3 is equal to, and then same thing over here, negative 1 times this guy over here. So we're going to have, again, our base, 8, raised to the, let's see, positive 4 plus x. Okay, so then again, we can drop these guys. So now we can say that 15x minus 3 is equal to 4 plus x. And then here to solve for x, let's move them to the left. So minus x, and then move the numbers to the other side. So plus 3. So 15 minus 1 is 14. So 14x is equal to 7. All right, so then here we can see that x is equal to 1/2 or 0.5, whatever you want to write it as, right? There's your answer. All right, now we're going to switch it up a little bit. So we have 5 raised to the x is equal to 33, all right? So we're trying to solve for x, right? So we need to get rid of this 5, the base, somehow. Now, whenever your x is in the exponent, the way that you get rid of the base is by taking the log base of whatever number this is, 5, of both sides, all right? So we're going to take the log base 5 of 5 raised to the x, and that's equal to the log base 5 of this side, which is 33, okay? So then over here, the log base 5 and the 5 cancel each other out, and then we're just left with what's ever in the exponent, so just an x in this case, right? So we get that x is equal to log base 5 of 33, and you're going to need a calculator to solve that, okay? So you can plug this into your calculator just like that if it allows you, but if not, another way you can solve this is by, this is the same thing as saying log of the big number, so 33, divided by the log of the little number, the base, 5, okay? So then if you plug this into your calculator, you'll get that this is approximately equal to, so we'll say that x is approximately equal to 2.17, right? We'll go 2 decimal places, right? So then this is your answer right here. Okay, here we have 11 raised to the 6x is equal to 38, right? So again, our exponent is in, or our x, the variable, is in the exponent, right? So we need to get rid of this 11. And again, the way that you do that is by taking the log base of whatever number this is, 11 of both sides. So we're going to say log base 11 of this whole thing, so of 11 raised to the 6x, and we're going to say that that's equal to log base 11 of this guy over here, 38, right? So then again, on this side, the log base 11 and the 11 cancel out, so then we're just left with what's in the exponent, so 6x is equal to a log base 11 of 38. Okay, and then to solve for x over here, we'll divide both sides by 6. So then we get that x is equal to log base 11 of 38 divided by 6, okay? Now, it's up to your teacher if they will allow you to leave your answer like this or not, but if you have to plug it into your calculator, then the way that you would solve this is by, again, saying, well, let's solve the top first. So log base 11 of 38, again, you can write that as the log of the big number, so 38, over the log of the little number, 11. So then you'll solve that, and then we're going to divide that by 6, okay? So then if you plug that into your calculator, you'll get that this is approximately 0.25, right? So then we get that x is approximately 0.25. All right, last one here. So we have 2 times e raised to the 2x minus 7 is equal to 5. All right, so the first thing we can do is get rid of this 7, right? So we get 2e raised to the 2x is equal to 12. And then we can get rid of this 2 by dividing both sides by 2. So then we get that e raised to the 2x is equal to 6. All right. Now, in order to get rid of this special number e, instead of taking the log of both sides, we're going to have to take the natural log of both sides. So we're going to take the natural log of this side and say it's equal to the natural log of this side. All right. So then on this side, the natural log and the e cancel out. And then we're left with, again, what's in the exponent. So 2x is equal to the natural log of 6. And then we can just divide both sides by 2. So we get that, let's write it over here, x is equal to the natural log of 6 divided by 2. Okay, and this will be a little easier to plug into your calculator because if you do, you'll get that this is approximately equal to 0.8 8, and we'll go 3 decimal places. 896, right? So there's your answer. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.